Good morning. Today we will discuss about universal shift registers. Before going into the universal shift registers, first we will discuss about what is a register, then what is a shift register, then what is a universal shift register. Then we will briefly discuss about those things, and we will go into universal shift registers. So what is a register? A register will be used to store some information. Register will be used for storing some information here. Okay. So it will be used for storing some values here like zeros, ones, and all those things here. Stream of zeros and ones here. Okay. Then what is a shift register? A shift register will be used to store data, but here what happens here is in the data will be shifting from one path to the other path. Okay. So from one direction to other direction. So the data will be shifted from LSP to MSP or MSP to LSP. So where the shift registers will be used and what will be the advantages of these shift registers. So mainly these shift registers will be used in multipliers. Okay. So multipliers, what happens here? We have to shift the data here. For shifting the data, we are going to use this shift registers. So, if you want to multiply any number by 2, just using a shift register by 1 bit, then and we have to part with LSP with 0, then what happens here, we can get the result. Okay. So that's why that's the advantages of shift registers. Suppose the shift registers will be used if you are going to shift it towards right, then what happens? It will be divided by 2. So these are the applications of the shift registers. So now we are going to discuss about the universal shift registers. So what is a universal shift register? So a universal shift register means it will be used for shifting all kind of shifting operations. It will be used for all kind of shifting operations. Okay. So like this, what happens here? I am going to use a shift register here. So in this shift registers, what happens here? I will be using this for as a serial in. So here the input will be entered as a serial input data, and it can leave the data by serial out. So here it may be either left direction or right direction. That way we are not going to bother about it. In both directions, what happens here? We can do the shifting here. Okay. Suppose if you are going to from the left direction, what happens here? From left direction it will be coming in and it will be moving like this. So in right direction also, if it is coming from it will starting from the right and it will be and moving one bit after one bit here. Similarly, we can use the parallel input also. Similarly, for using what happens here, we can use it for the parallel input data here. Similarly, we can use it for the parallel input data here. So here, like this, if you look into this diagram, here this one is the parallel data. If you look into this one is the parallel data here. So in parallel data, more number of bits will be coming in. So now what happens here? Like this, the data will be coming parallelly and it will be leaving parallelly. The shifting can be done from this direction. Okay. Similarly, vice versa, we can shift from this direction also. We can do the right shifting or we can do the left shifting. Both kind of shiftings are possible. Both kind of shiftings are possible. Okay. So here, how we are going to implement this is, we are going to implement with the help of a multiplexer. We are going to implement with the help of a multiplexer here. So multiplexer, what happens here? We are going to choose the multiple options here. We are going to choose the multiple options here. A and B will be there. Based on the selection lines, what happens here? I am going to get one of the value here. So multiplexer, what happens here? I am going to do the what kind of shifting I am going to do. Okay. So I should not do any shifting. No change. Or if I want to do the left shifting. Okay, or I have to do the right shifting, or I have to do the parallel, I have to load the parallel data. So for that also, what happens here? We are going to use the multiplexer. So we are going to use the 4:1 multiplexer. But briefly, we will discuss about the 2:1 multiplexer. So in this 2:1 multiplexer, suppose what happens here? I am going to have the value of A and B here. Suppose if my A value is equal to 0, A value will be equal to 0. Or B value is equal to 0. Whatever the value of A, if the selection line value is equal to 0, that value will be coming out. So here I assume that A value is equal to 0 and S value is equal to 0. So now what happens here? This AND gate, what happens here? A value will be 0 coming here and S bar. So 0 will be inverted and it will be coming here. So 0 and 1, AND gate output will be 0, and it will be, here we had to wait for this. Here also B value is 0 and the selection line value is also 0. So now what happens, directly we are going to give the value here. So here what happens here, this S bar value we directly connected here. So 0 and 0, both the things will be 0 and 0 means 0. So both the AND gate outputs are 0, we are going to get the output as 0. So for better understanding what happens here, now I am assuming that A value is equal to 1. Now I am assuming that A value is equal to 1. So if A value is equal to 1, what happens here, the shifting will be, what are the value of A, that A value will be coming out. A value will be coming out here. Let's check it out. S value is equal to 0. S value is equal to 0 means this NOT gate output will be coming as 1. So now A value I assumed as 1 and this S bar value I assume it as 0. So if I assume it as 0, then what happens here? This AND gate NOT gate output will be 1. So for this what happens here, for this AND gate both the inputs are 1. If we apply both the inputs are 1 and 1, here we are going to get the value as 1. Okay, so it does, if the OR gate, if one of the input is 1, definitely we are going to get it as 1. Anyhow, we will check the other one also. So here what happens here, we are going to get the 0 and I assume that B value is also 0. So 0 and 0, here 0, 1 and 0, we are going to get it as 1. So this is the basic operation of a shift register. This is the basic operation of a shift register. Okay, now we will discuss about the So now we are going to discuss about the universal shift registration table. So this is the main functional table. So here we are going to have the multiplexer, we are going to have the two selection lines now. So based on this only we are going to do the operation here. So 0 0 means what happens here, there won't be any change here. So what are the previous output will be there? The previous output we are going to take it here. 0 1 means we are going to do the shift right. 1 0 means we are going to do the shift left, and 1 1 means we are going to use it for the parallel data. We are going to use it for the parallel data here. Okay. Please try to remember here 0 0 means no change. So based on these connections only we are going to give it to the multiplexer. 0 1 shift right, 1 0 means shift left, 1 1 means parallel load here. So now what happens here, how to remember the connections here. So here nothing is there. We are going to use the 4 flip-flops here. We are going to use the 4 flip-flops here. Okay. And we are going to give the active low clear signal. We are selecting the active low clear signal. So if we make this value as equal to 0, then what happens here? All the flip-flop outputs will be cleared and we are going to get the values as 0. We are going to get this values as 0 here. So if I made this value as equal to 0, if I make the clear value as is equal to 0, then what happens here, defaultly all the flip-flop outputs will be also resetted. Okay, because it is an active low signal. Here look at into the bubble here. So that what happens here, if you make this value is equal to 0, all the flip-flop outputs will be 0. All the flip-flop outputs will be 0, and we are going to get this output as 0 here. Okay, and all are synchronous flip-flops. So what happens here, we are going to give the same clock to the all the flip-flops here. We are applying the same clock to the all the flip-flops here. Whenever we are applying the clock signal here, at that time all the flip-flop outputs will be changing here. Okay, if we look at here, we are going to use the 4 multiplexers. For all these multiplexers, S1 and S0 selection lines are connected here. Okay, if the values are 0 0, if the values are 0 0, then what happens here, whatever the input applied at 0, that value will be coming out, and that value will be given to the D flip-flop input here. That value will be given to the D flip-flop here. Okay, so multiplexer output values will be there now. They are directly connected to the D flip-flop here. Multiplexer output value will be there now. It will be connected to the D flip-flop. Multiplexer output value will be connected to the D flip-flop here. So if you look at here, what happens here, these 4 are the inputs here, these 2 are the selection lines, and this one is the output Y. This one is the output Y. Okay, so this output will be connected to the D flip-flop here. This output will be connected to the D flip-flop here. This output Y will be connected to the D flip-flop. This flip. Now what happens here is all these multiplexer outputs are simultaneously connected to the flip-flop inputs here. All these things are connected to the D flip-flop here. Okay. So this output will be connected here. This output will be connected here. This output will be connected here, and this output, multiplexer output, will be connected here. So now what we are going to do here is, so for 0 0, what operation should be done? They should not change in the output here. It should not change in the output here. So what we are doing here is, so I'm coming from the MSB here. Okay. So for the MSB flip flop, what happens is, what should be the output? So for 0 0, just we look into the truth. If you remember the truth table properly, for 0 0, what happens here? It should not change. So that's why I'm going to connect the A3 output again to the multiplexer 0. So the fourth flip flop output will be connected to the fourth multiplexer 0th input. Again, third flip flop output will be connected to the third multiplexer 0th input. Second D flip flop output will be connected to the second multiplexer 0th pin. And similarly, the first D flip flop output will be connected to the first multiplexer's 0th pin. So that's why what happens here, if I give the selection line values as 0 0, then what happens here, this pin, what are the input connected to this, that value will be connected, coming out. So now what happens here, what value will be connected out? If I selected 0 0, so here A3 value will be connected here. Here A3, here A2 value will be coming out here. Here A1 value will be coming here. A0 value will be coming here. A3, A2, A1, A0. So now what happens here, they are simultaneous. Whenever we apply the clock signal, these values will be coming out. Previously, what are the values? A3, A2, A1, A0. Now also we are applying A3, A2, A1, A0. So we are going to get the previous output. We are going to get the previous output here. We are going to get the previous output here. Okay. So this is for 0 0. Now what happens here? I am applying the 0 1. I am applying the multiplexer. What value I am applying? I am applying 0 1. So 0 1, what value will be there? It will be the right shift. For 0 1, what happens here? Right shift. So right shift means what happens here? Whatever the first, I am going to apply input for this. So this output, this flip-flop output will be there, no? This output value should be connected to the input of this. This output, just I am drawing it, I am going to erase this. Just briefly what happens here, I am going to show this. Okay, so this output will be connected to this. So now I have to do like this. So but I am going to use the multiplexer, no. So it has to come through the multiplexer. It has to be come through the multiplexer. So now what happens here? I am going to connect here. The first one, what happens here? Serial input, shift data I am applying here. Just now I told you, for this one, what value I need to get? A3 value I need to get. That's why A3 value it will be coming here. From here I am connected to one of the second multiplexer. Okay, first pin of the third multiplexer. Here A2 is the third flip-flop output. The third flip-flop output again will be given to the second flip-flop input I need to get. So that for that what happens here, when we need to get that, when the condition is 0 1. So for that one, what happens here, I am going to connect it here. Next, A1 will be connected to the first pin here. Like this, what happens here, we are going to apply all the inputs here. We are going to apply all the inputs over here. Okay, like this we are applying here. So if you apply the 0 1 here, what is the condition here? I am going to get the, simply I am writing here, serial input right. I am going to get the serial input right. Because I am applied 0 1, no, what value I applied here? Input data. From serially input right data will be coming here. And what value will be coming here? Here 1. Now what happens here? We are going to give the A3 value will be coming here. Because see, look at here, what value will be coming here? A3. Here now what a value will be coming here? A2. Here A1 value will be coming here. So now what happens here? I am going to get the value like this. Okay. Now if I apply the new input will be applied here. No, that value will be again will be coming here. This SIR will be coming here. A3 will be coming here. A2 will be coming here. If you apply one more clock pulse, this SIR will be coming here. Here what are the value applied? That value will be coming here. So these things will be coming out as an final as an output there. Okay. This is what shift reached. Shift. We are going to shift the data towards range. Okay. Generally, this right shifting will be used in the multiplication. Generally, it will be used in the division. Sorry, it will be used in the division here. Okay. Now, what happens here for the multiplexer? I am going to apply the input as 1 0. I am going to apply the input as 1 0 0. So if I am going to apply the input as 1 0, it has to do the left shift. It has to do the left shift. So here from this direction I am going to get the inputs here. From here I am going to get the inputs here. Okay. So previously I written no, like that only I am going to write. So here what value will be coming? Serial input left. Here this value. Okay. Okay. I will draw like this. This output value will be there now. This output value will be applied to D. This output will be applied to D. This output value will be applied to D here. Like this we need to get. Okay. So how can we get that? So here for the second pin I am going to apply the serial input left. I am applying the serial input left here. Okay. From the serial input left I am going to get here. So when I apply the clock pulse, that value will be coming out. Here A0 value. That's why if you look properly here, this A0 value will be connected here. Here A1 value will be connected here. Now similarly here also we are going to get this value here. Okay. Previously this value will be coming here. Please see properly. Like this we are going to get. Okay. So that value will be coming out. So like that what happens here? The serial we are going to do the left shift. We are going to do the left shift here. Okay. So finally what happens here? We are going to apply the 1 1 here. I am going to apply 1 1. So if I apply 1 1, what happens here? The parallel data shifting will be done. Like what happens here? It will be the parallel data shifting. So here I am going to apply the I3, I2, I1, I0. Third pin I am applying I0 of this first multiplexer. Second one I am applying I1. Next I am applying I2, I3 here. So that what happens here? I am going to get I3, I2, I1, I0 here. So these values will be coming out at the parallel outputs here. Okay. So previously we discussed about the left shift now, where it will be used. Generally it will be used in the multiplications. Okay.